In this video, I'm just going to look at a few more examples of graphing using that idea of anticipating what to expect and then graphing by plotting points, okay? All right, so let's say we're trying to graph y equals absolute value of x plus 5. It's an absolute value there. All right, so what you should think is it should be like y equals absolute value of x, which you should know looks like a V. You should be thinking V-shaped, okay? Now the V could be left or right, up or down, could even be flipped over. Sometimes it's not in that exact orientation, but you should be looking for a V. So watch what sometimes happens to people here, okay? So people sometimes do this. They come in and they graph, 0, 1, and 2, or they find ordered pairs with an x of 0, 1, or 2. So if you put in a 0, you get absolute value of 5, which is 5. Put in a 1, you get absolute value of 6, which is 6. And 2 would give you absolute value of 7, which is 7. Okay, so then they go and they plot that. 3, 4, 5, 6, 7, 8, 9. So 0, 5, 1 is at 6, 2 is at 7, and so on. So it looks kind of like a line. So now they're thinking it's kind of a line. So then they go in and they maybe pick a -1. When they do, they get an absolute value of 4, which continues their thought that it's a line. So what a lot of people do at that point, if they haven't thought about this first, is they say, oh yeah, it is. It's just a line. So I'm just going to go and draw that line, and that's my graph. Okay, but that would be incorrect. That would be wrong. Not V-shaped, right? It's supposed to have a V. So they kind of jump to conclusions too soon. So if you know it's supposed to be V-shaped and you're not yet seeing the V, then you need to keep exploring a little bit. Okay, if I put in a -3, I would get absolute value of 2, which is 2. Okay, so that's still, along that line. So you still might not think anything about it. -4 would be absolute value of 1, which is 1. Okay. So -4 would be here at 1. Okay, still continuing kind of that linear look. But then when I get to -5, I wind up getting a 0 inside there, and the absolute value of 0 is 0. Okay, and when I go past that to the left, like at -6, then I have absolute value of -1, and that's where the turnaround happens. That's where, when we get over here, we're turning around finally, and we figured out where the V happens. And so now that I know it's supposed to be a V, and I found where that turn happens, then I can just go ahead and sketch it, and I've got my picture. Okay, but if I had followed most of what I found was, get that to be blue, was here, and if I drew the wrong conclusion, I might have thought that was the graph, but that's not true, because it should be a V shape, and if I had explored further, I would have found the V. So I think if you combine graphing by plotting points with knowing what the basic function is and what it should, or the basic relation is and what it should look like, you'll be in good shape. Okay, all right. And so if we tried to graph something like we do x squared plus y squared equaling 9. Okay, so if I try to graph that, I'm thinking it should be a circle. Okay, so then when I go and I build my table, I'm going to pick maybe a 0 for x, and I can see y squared would have to be 9, which means y would either be 3 or -3. So 0, 3, 0, -3 would be 2 ordered pairs I'd get from that. Then if I put 0 in for the y here, x squared would be 9, and I'd get a -3, 0, and a +3 with a y of 0. Okay, well, if I know it's a circle, that's really all the points I need. Here's my 0, 3, here's my 3, 0, here's my negative 3, 0, here's my 0, negative 3, and I know it's a circle, so I don't really need to go exploring anymore. I can just go ahead and draw a circle with a radius of 3. You see how it really cuts down on how many ordered pairs you need to find? Okay. All right, so you really want to work at this point to work a little more on the basic graphs. You know, sketch out a few more of the ones that are on that handout that I posted. Not in my math lab, but just in Blackboard. I have a handout called Basic Graphs. Go ahead and create a sheet that shows what all of those look like and start kind of studying that maybe a little bit each day just to associate the equation with what its basic graph should be. All right, and then we can graph some of those examples that I put on the sheet that I called graphing equations in 2 variables, some examples. Okay, I want to do one more though that's not on that sheet. I want to look at something like y equals, we did square root of x minus 5, okay? But what if it had been a 5 minus x? I just want to kind of show you what can happen. And then I also want to do another one that's just a little bit strange, okay? So it's square root. I'm kind of thinking this. That's what y equals square root of x looks like, okay? So then I'm going to get my table of values, start plotting a few points, and I can see 0 would always be a good thing to do, even if it doesn't turn out nice. Turns out to be square root of 5. And the square root of 5 turns out to be a decimal that goes on forever. So an irrational number, but it still has a location in the real number coordinate plane. It's about 2.24. All right, but if I want things to turn out nicely, I might pick a 1, because that would be square root of 4, which is 2. Okay. I might pick a 4, because that would be square root of 1, which is 1. Okay. Right. Let's see. Oh, you know what? If I pick a 5, I'd get square root of 0, which is 0. And then I might even go and look at something like a negative 4, which would be square root of 9. 5 minus negative 4 would be square root of 9, and that would be 3. Okay, so then I go and I start plotting some of this. Okay, 1, 2 would be here. 4, 1, 5, 0. 1, 2, 3, negative 4, 3. And then if I pick something like a 6, I get a negative number under the radical, which is imaginary. So I can't put it in a real number coordinate plane, so there's going to be nothing over here. So I think this is going to be the like what corresponds to that spot, but instead of going to the right like the basic one did, it goes to the left. And then it seems like it would just keep going like that. So it still has that kind of one-sided, you know, starting from somewhere and going one-sided with a little bit of a curve to it. But you see how it can be flipped around, or it could be flipped over, okay? All right, and I want to do one more on this. I know it might be getting long, but let's take a look at one more. Let's look at something like x equals y squared. This is a basic graph. So on the basic graph sheet, I want you to take a look at this one, okay? All right, if you tried to, we don't know what this should look like, but we know that y equals x squared looks like this. So might be expecting something like that, but let's see what happens here. Now, this one I think would be easier to be plugging in for the y and seeing what x is, but y is still going to be the second coordinate, so still keep your table set up this way. But then if you want, pick y values of 0, 1, 2, maybe negative 1, negative 2, kind of see what you're getting, okay? When you plug in a 0 for y, square it, you still have a 0. That would be the x. Put a 1 in for y and square it, you get a 1. Put a 2 in, you get a 4. A negative 1, don't forget that negative 1 gets squared. So you're still going to get a 1. Put in a negative 2, you get a 4. So when you go to graph this one, this point is on it, then you get 1, 1, 4, 2, and then you get 1, negative 1, 4, negative 2. And then what about, though, when I try to look to the left here? Like, what about a negative 1 for x? If I put a negative 1 in for x, I have something being squared trying to be equal to a negative 1. You know, y squared equal to negative 1 means y would have to be plus or minus the square root of negative 1. That's imaginary. And even though we can like write plus or minus I for that, we can't plot that in a real number coordinate plane. So there's no points over here. So this one still had that kind of U-shaped look, but it was turned over. See how that x was by itself instead of the y being by itself? Okay. A similar thing happens, by the way, with absolute value. Y equals absolute value of x is a sharp V like that. X equals absolute value of y is a V on its side. Okay. All right. So at this point, I'm going to stop. What might help would be if you'd go and try to complete the basic graph sheet and then maybe work on graphing some of those examples that are on the sheet that says graphing equations in 2 variables, some examples. Both of those are posted in the folder on graphing. And at some point I'll post some responses to that or post an answer to that. Because let me